Okay, I like this problem. I've actually already done this one on the board. I'll go ahead and make the video though now. We're considering passwords of length 4 made up of characters. At least one and at most 3 of the characters is a special character chosen from a group of 15 special characters. The remaining characters are chosen from a list of uppercase and lowercase letters. So the size of let's call S to be a special character and L be a lowercase letter. We're going to, for part A, write down all the valid categories of passwords, okay? SLLL, LSLL are valid password categories because they have at least one special character. It's supposed to be one there. However, LLLL is not a valid category of password since it does not satisfy the rule of at most 3 of 4 characters are special characters. Okay, so actually all L's is it's not a valid password actually since it does not satisfy the rule that at least one must be a special character. That's actually a typo there. In any case, the categories of password are as follows. I can either have at least 1 and at most 3. I can have those with one special character. So I can put LLLS. There's one special character in the last place. I can move that special character to 4 different positions. Okay? And those are 4 different categories of password with one special character. Then I can have 2 special characters. L, L, S, S. LS, LS, SLLS, SLSL, SLL. Ooh, what am I doing here? What am I doing? I'm bringing the S's back, right? LL, I think LLSS, LS, Oh, I didn't do it right. Let me go ahead and go back a notch here. If it were zeros and ones, I think I'd be better at it. LLSS. I'm still with an L in the first one. SSL. There we go. Those are all 3 of the possibilities where I have an L in the first one. And now I have an S in the second one. S, LLS, SLSL, SSLL. Yeah, those are the other 3. You can think of it as when I've got the S in the first position, then I've got 2 L's and an S, and there are only 3 positions for that S. When I have the L in the first position, I have 2 S's and an L, and there are only 3 positions for that L. Okay? Finally, I can make passwords with 3 special characters, right? At most 3 special characters. So I have an L, S, S, S. And now I only have 4 of them because there's only 4 positions for the singular L in the list. Okay? Okay. That's part A. That's the categories. Now use the product rule to calculate the number of passwords in each category. Oh boy. Okay, so here's category 1, where we have 1S. Category 2 is the 2S category. Try to write neatly here. And category 3 is the 3S category. The 1S category, the number of them, is equal to the product rule, and let's just do the LLLS version of it. And so that's this first one. Okay, how many different normal characters are there? L. L is an uppercase or lowercase letter. There are 26 of them. So there are 26 possibilities for the first L, 26 for the second. Passwords can repeat letters, right? And there are only 15 special characters. And this is 26 cubed times 15. And I think I have to write neatly. Okay. I'm going to run out of the number of 2s categories. In the 2s category is L, 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 S, S. And again, I'm just only taking one of them, L, L, S, S, as a way of writing down the number. And here I'm going to get 26 times 26 times 15 times 15, or 26 squared times 15 squared. And there were 6 of those. And number of 3s is boom, 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 boom. And the number there is going to be, suppose it's L, S, S, S. It's going to be 26 times 15 times 15 times 15, like an L, S, S, S. And this is 26 times 15 cubed. Okay, the total number now. Use the sum rule to calculate the total number of valid passwords under these rules. The total number is equal to 4. There are 4 different varieties. 4 times 26 cubed times 15. Plus, there are 6 of these with the 2s varieties. 6 times 26 squared times 15 squared. And finally, there are 4 in the last category of 26 times 15 cubed. And I don't know what this number is. I guess I can calculate it. Equals 4 times 26 times 26 times 26 times 15 plus 6 times 26 times 26 times 15 times 15 plus 4 times 26 times 15 times 15 times 15. 326 is 115, 6, 226 is 215, 4, 126, 315s, and I get 2,318,160. Okay? And so I've used the sum and the product rule here. Notice that in each of these calculations, for 1s, 2s, and 3s, I've only calculated the total number for a particular one of the patterns. Okay, so this number in the 1s, this 26 cubed times 15, only gets me those with the LLLS pattern. But that's the same number as the LLSL pattern, the same number as the LSLL pattern, and the same number as the SLLL pattern. Because we can just rearrange 3 26s and 115, 3 26s and 115, etc. So I've used the sum rule sort of two ways here at 2 different levels. I use the sum rule to multiply this value times 4 times this value, 6 times this value, and 4 times that value. So I'm using the sum rule there, and then I'm finally using the sum rule to add up all 3 categories, and I put these pluses in here. So hope that helps. I think this finishes out that homework set.